Welcome to SErea's Spotlight series. Today's presentation is a net zero ready MURB solution and Alberta's power grid. The SErea Spotlight series brings to industry shared learnings from real testbed projects as part of the GBTN, which is the Green Building Technologies Network. And today's shared learning webinar is being brought to you by Landmark Homes in collaboration with the University of Alberta. This project is one of 15 demonstration projects funded in part for innovation towards accelerating the adoption of innovative low carbon solutions for buildings. And before we begin, I'll give a quick introduction to SErea, which is the Smart Sustainable Resilient Infrastructure Association, and some acknowledgements. So I have a screen up here. This is our website. If anyone has visited or would like to visit it, that's www.serea.ca to get here. SErea is a non-for-profit organization with the mission to accelerate the adoption of innovative low carbon solutions for buildings. We work collaboratively with industry, post-secondary, and small medium enterprises towards achieving this goal, which includes funding for demonstration projects like this one that you'll see today, business growth programming, and networking. Stay tuned and visit our website to learn more about the GBTN, SErea, and more webinars like this. You'll also be able to find this video presentation afterwards on the Landmark page. So quick acknowledgement here is necessary and customary. Let me start by acknowledging the First Peoples on whose traditional territories we live and work, and from where we are presenting this webinar. Feel free to recognize a First Nation from where you are if it's not in one of these territories, if I'm not covering them all here. I have a map up showing our Treaty 6 and Treaty 7, both the Edmonton and Calgary areas, from which include the Blackfoot, the Siksika, the Piikani, the Kainai, the Tsuut'ina Nation, the Stoney Nakoda First Nations, the Métis Nation of Alberta, Region 3, and the Cree, Saulteaux, Métis, and Nakota Sioux people. So thank you, and a recognition that we're on their lands. So as we'll get started here slowly with no further ado, I'd like to introduce Dr. Haitao Yu, who obtained his PhD degree in construction engineering and management from the University of Alberta in 2010, and then joined Landmark Group to lead its research and development department. In the past 10 years, he initiated and managed over 20 government-funded research and development projects, including this one. And we are very happy to have him here today to be presenting. A bit later on, we'll be joined by Dr. Chen, who is an associate professor of building engineering in the Department of Civil and Environmental Engineering at the University of Alberta. He obtained his post-secondary degrees in building engineering from Concordia University in Montreal, Canada. Dr. Chen joined the University of Alberta in 2015. His research expertise is on high performance buildings with a focus on energy efficiency and peak demand reduction through thermal energy storage, daylighting, intelligent operation utilization of renewable energy, and their intelligent and integrated design and operation. Dr. Chen is currently serving on the board of directors of the International Building Performance Simulation Association, the IBPSA, the Canada chapter, and also on the board of directors of the the Canadian Standards Association. So we're glad to have both of Dr. Chen and Haitao with us today. So with no further ado, I'll pass it off to Haitao and we will begin.
Okay, hello everyone, and thanks again for the kind introduction. And then before we go into specific project, I want to have a brief introduction of Landmark's net zero journey. Actually, we started from 2011, actually, it's exactly 10 years ago. And at that time, we built our first net zero show home in Calgary, in Cranston. And then for that, you can see that show home in my background. So for that is the first one is a very early one. And then at that time, actually, we kind of found NZEers to help us to do the energy modeling and design. So we did almost everything by ourselves. And then start from that, the next year, we built another net zero homes in Edmonton and 14-unit townhomes in Edmonton. So that is kind of the start of our journey. So you can see the lines there, and recently started from last year, our focus start to move to NZEr energy ready multi-family buildings. So for that is also is kind of 2020 national building code has changed. It's become a step code. So in 10 years, all the new builds will have to achieve NZEr ready standard. So we want to develop a viable solution to meet that goal. So in the past 10 years, Landmark has already built 30+ NZEr energy homes and 80+ NZEr energy ready homes. And thanks to the support from SErea, in this year we start a new project, and then build a NZEr ready MURB building. In that rental community is located in a Maple Crest community in southeast Edmonton. The project owner is SErea Holding, and Landmark is the design builder for this project. The entire project has more than 100 units there. And then one of the building you can see is here is a block 3 will be upgraded to a NZEr ready standard. And then we also do the energy monitoring for another building, which is our standard spec. So it's kind of as a reference building. So we will clear to know what is the difference between the cost and the energy performance. And also in one of the purpose of this project is work out what is the energy profile of all those buildings. So we can have scientific ground knowledge for our future projects. And the project, there are 3 partners in this project. Landmark Homes, mainly in charge of the design and the construction of NZEr ready MURB, and the entire project. SolarMax is our long-term partner of a solar PV system. So it will in charge of the design and the installation of a small solar PV system on that NZEr ready MURB. The University of Alberta mainly in charge of design and install energy measuring system, and also at a later stage will help us to develop a microgrid simulation tool. Here is the building. It is a 9-plex, but because there are stacked townhome units at the 2 ends of the building, so the total units is 11 units, including 4 stacked units. It's between 900 to 1100 square meters, and 7 3-story walkout townhome units in the middle. So the table shows energy monitoring results. So if you see that, you can see for the stacked units, the total energy saving is about 50%. Because it is the end unit. So the effort on the building envelope have a big impact on the utility, on the energy savings. And for the middle unit, it's about 40%. of the energy consumption reduction, although the building envelope, if we only consider the building envelope, it will save energy more than 65%. But because mainly the load will be on, we call it a base load. Mainly it's kind of lighting, appliances, and computers, all kind of plug-in load. So for that one, it's very hard to kind of reduce. So for that is our, but 40% on average, 43% is pretty good, because if we consider the requirements in the STEP building code 2020, the national building code, actually we are already pretty close to tier 4. So now we are at the tier 0, right? So we are almost the entire the 2030 goal is tier 5. So we are pretty close to that goal. Now we can, if we go into see all those technical details of a net zero energy ready townhome for that workout, units is quite standard. All our net zero specs is look like this, and also is pretty close to similar to other builders who build multi-family net zero homes. So it's a ceiling 2x4 trusses with R60 blow-in Arctic insulation. And the main wall is the same as 2x4 wall with R22 bed in the cavity. That is now the standard in a housing market. The only difference, we add 1 inch of exterior XPS insulation on the outside. Is like you use a blanket, R5 blanket, wrap the building, and then we also put in the slab on ground. For that 3-story, there is no basement, so we have a slab on ground. So we put in 2 inches of type 2 EPS R8 under the slab. Windows PVC frame, triple pane 2 low E argon, but that is the standard now for high performance residential building. And the air tightness, our target actually is 1.5, but I think we can make sure to hit 2.0 air change per hour at 50 PA. If you know, for the townhomes, this is pretty hard to achieve, because normally if you go into the regular townhomes built on the market, it's very easy about 3.5. So air tightness is a key to make the unit very energy efficient. Another thing is we call it a compartmentation. This means we have the poly on the party wall, so the air will not move from unit to unit. And what is the kind of innovation here is the heating system in those units are not the conventional system. We call it a dual fuel hybrid heating system. But that is, you can see, for that is the system diagram. So you can see here, instead of a traditional natural gas furnace, here actually is the fan coil. So that fan coil actually received 2 heating sources. One is the outdoor air source heat pump, and another one is they can receive hot water from a Navin tankless hot water heater. So when the outdoor temperature about minus 10 degree, and for that fan coil is get heat from the air source heat pump, and then for that they have very high COP. Is a COP will about 2 or 2.5. For that means 1 unit of power. The electricity we use, and then we can get 2.5 heat from air source heat pump. And then when the outdoor temperature go lower, and then the entire system will switch from air source heat pump to a tankless hot water heater. So for that, it will fit in the hot water into that fan coil, and then to heat the house. The entire system is controlled by outdoor temperature sensor. And then for that, in the past, at the beginning, when we designed this system, we thought we need to the HVAC manufacturer need to provide a control, but now you can buy on the market. It's already this type of system, the control system already integrated into the thermostat. So now we are now you use a Honeywell thermostat. It can control the dual field system. So for that is the new system. Actually, I think we are the only one in Alberta now use this type of system for our highly energy efficient homes. So for that, and then there are all others is kind of regular for NZEr homes. We are introduce our hot water is provided by a Navi tankless water heater, and HRV is a high performance fan type Hero 1, and also we have drinking water heater recovery system. And why we use dual field hybrid heating, that is probably a question. Actually, for that is kind of the trend. We are a part of CHBA National NZEr Home Labeling Program. And then in the past, NZEr Council, CHBA NZER Council, it has a NZEr labeling program. Now is 3 years, and then so for that you can see what is trend over there. And so far, the most recent number, actually the total NZEr and NZEr ready homes labeled by the program now is already past 600. So, but if we go and see the table here, it's actually in the past 2 years, 2019 and 2020. There you can see it's kind of a significant increase in the houses participate in the program. And then here is the list of the heating system is using there. Actually, it's kind of before most of NZEr homes, they use air source heat pump plus electric for furnace for that buses. Even for us, we are in Alberta, if we build NZEr home, we still use that type of system because of here in Alberta, the Microgen Act doesn't allow to use a solar PV generation to offset the natural gas energy consumption. So if we want to heat a NZEr goal, we have to go kind of 40 electric for the house. But now if we can see this actually in the first start from last year, and actually the last year you can see most of the homes actually is net zero ready homes. The trend has a little bit changed. So for that is why actually last year the air source heat pump with a natural gas condensing furnace become a trend. So you can see here actually it is accounted for if we got it's almost 75% in last year for the old net zero and the net zero ready homes labeled by the program. And even actually it's even because of that is a combo domestic water system. This H system actually done by us. Where for that we can also call because it also has an air source heat pump, so it also can be put in this category. So for that is where we see for this is the trend. For that is the trend here. We are kind of lead that trend in Alberta, but there are already a lot of this kind of system in Ontario. And for here is kind of the reason why now the dual fuel hybrid heating becomes so popular. The first thing is if we see all those two charts, because the air source heat pump actually is kind of extract the heat from the outdoor air. When the outdoor temperature go down really low, for example, below minus 20, it will be really hard for air source heat pump to get heat. So for that is reason, if you see those two charts is provided by Mitsubishi Aruba climate air source heat pump manufacturer. You can see here the line is over there. The top is the total capacity. Although you see the total capacity is still okay. When it's go to minus 20, minus 30, it's go below a little bit, for example, 80%. So it's still okay, meet the requirement. But if we can see the COP, but that is the blue line, you can see if the outdoor temperature go below minus 20, and then the efficiency of the air source one will drop pretty close to 1. This means you get in use 1 unit of the power, you can only get 1 unit of heat. So it's kind of basically the same with using baseboard heater. So for that, but that is there's no meaning to use electricity to heat the house, because the electricity, if in terms of the heating you can gain from electricity, actually much more expensive than to use natural gas to heat the house. Because now in Alberta, the price of electricity delivered to the site include both the cost of energy and the cost of all those deliver fees is about 13 cents per kilowatt hour. Actually, in this year, it's much higher than that, because now the energy price, if you are available, is over 10 cents per kilowatt hour. So the overall cost will be about 16 cents per kilowatt hour. But by the way, we just assume you are on a fixed one plan, and then it's now is 30. So if we convert it into gigajoule, it's about $36 per gigajoule. But if you can, what is the price of a natural gas to today? The energy price about $4, and then add all the fees. will be less than $6. So if you compare that, if you use natural gas, $6 per gigajoule, and you use electricity to heat the house, $36 per gigajoule. So for that, you can see electricity is 4 to 5 times more expensive to generate the 1 unit of the heat. So for that is the reason why for net zero homes probably is not apparent, because all the electricity consumption of net zero homes will be offset by the solar PV. But for net zero ready homes, because there's no that offset. So for that is, if you use the electricity to heat the house, the operation cost for the homeowners will be really high. And the other benefit to use a hybrid system is reduce the peak demand. The last reason is why we build net zero homes or net zero ready homes, because we want to reduce the GHG reduction. But the Alberta, you see the title of this presentation is have Alberta electricity grid. Because every time we design net zero home, we need to consider the background. So in Alberta, we can call it Alberta energy, the intensity, GHG intensity of the Alberta electricity grid is really high because of all the coal-fired plant. Even it's going down, but still pretty high. Actually, this number 0.53 is based on Alberta governments. They call it offset intensity. It means if you install a solar PV renewables, you need to use this number 0.53 ton CO2 equivalent per megawatt hour. But actually, the actual intensity is higher than that, because for that is already considered 10 years in the future, or the intensity of the grid will go down. To today's, this number is 0.66. How about you using natural gas? Natural gas, the intensity will 0.2. So you can see using electricity, actually, the GHG emission of using electricity to get the same amount of the heat is about 2.5 times than using natural gas. Now, nationally, there's a lot of provinces like BC and Ontario. They are pushed for, they call it electrification of the residential buildings. But for that, it is because their grid is very, very clean. Because for example, for Ontario, and their intensity is 0.04 ton CO2 equivalent per megawatt air. And then for BC, it's even lower. It's 0.01 because more than half of their electricity comes from hydro. So for that is when we design the net zero homes, we pick the technical solution. We need to consider what is the ultimate goal of our net zero effort, and then what is the background to this. So for sure, in the future, I believe Alberta grid will become greener, but there is a balance here. But that is why we kind of promote the for net zero ready homes today in Alberta. So for that is the stacked townhomes. If you see all those the building envelope, they are exactly the same with all those standard townhomes because they are in the same building. It's not viable to change those. but for here, a little bit different here. Is mainly is on the heating system. The stack guns we use a mini split air source heat pump and electrical baseboard. Mainly for that is kind of a little bit conflict in my statement in the before slide. For that, for all those homes, there's no natural gas units. For all those units, there is no natural gas connection to the units. It uses 100% of electricity for all those units. Mainly is because we need to kind of balance the cost. We need to consider what is the construction cost, what is the kind of operation cost of all those units, because the stack unit is the low end. It's a low end product. The budget for that is kind of very tight. So we want to make the net zero solution as low as possible. So if we consider this, the construction cost can compare to use natural gas to heat the units. It's kind of, you can see over here, we can save about $1,300 per unit. And then on the operation cost side, probably for every year, the residents need to pay probably $206 more. So we can consider this, and then at the end, the owner decided, the developer of the project decided we will pick the option 1.4 with the spec listed here. So and then last I want to see, for that we put a small solar PV system on the rooftop for this NZEr ready building, because we want to see what is the interaction between the solar PV system and solar and energy consumption of the unit. So we can, the table here is this how the size of the solar PV system and what the percentage of electricity consumption offset by the solar power. We are normally based on the data analysis of over 100 solar PV sites we installed in the past probably 10 years. And then we come up the on-site usage of the solar power will around 20 to 30% of the total energy consumption of the units. So for that is why we kind of design the size of system, because we want to see how much of solar power will be used on site and how much power will go out to the grid, and what is the energy profile of this. So for that is that in order to get all those data, we put in energy monitoring system installed in 2 houses, both the NZEr ready building and also the reference building. You can see for the townhome units, we measure both electricity and natural gas, and then for the stack unit, because it's only has electricity consumption, so we only measure the electricity. Dr. Chen will introduce the details of those monitoring systems. And then you can hear the project goal we have is twofold. One one is we want to demonstrate affordable and replicable solutions for multi-unit residential buildings. We call it MURB. So how it can achieve a net zero ready performance, which means 40 to 50% better than current coal. And another purpose of this project is to develop a generic simulation tool to predict and analysis the aggregate energy profile of net zero and net zero ready buildings on community level. Why this is very important? I want to see in this. Here is the current the design, the electricity, the utility system design for this project. You can see those four are four transformers for this townhome project. Entire project has 104 townhome units here, and they all connected, and then from here connect to the grid. So this community will be a microgrid. And now for each transformers, if you look at all those, it's connect to 3 or 4 buildings, and has to be between connect to those buildings and between let's just see, for that is ampage. It's kind of 800 to 1200 amp service. So for that is but for this is mainly designed for the coal, the comprehensive buildings. You can see the table here in the coal comprehensive buildings. Mainly we only use electricity for the base load and also the HRV. So the average for every unit, the annual consumption will be about less than 8,000 kilowatt hours. And here, if we go to a net zero ready building with a hybrid heating, so that number, the consumption number will go up a little bit because we use we use about 800 kilowatt hours on heating, and but on the other side, because our lightings and the base load, there's a little bit reduction over there. So it will be lower on this side, but because of we have air source heat pump, so the air conditioning will be added in. So overall, go in and out, it's a little bit higher than the conventional building. But if we go to a net zero standard, there's a lot. There's almost more than 30% of increase of the overall energy consumption. But for that is, although here is 30% not much, but if we consider the infrastructure not deal with the annual load, it will need to have the capacity to deal with the peak load. For that is actually is a lot change, but we don't really know how much the peak load will be. We just think it will be much higher because the things you can consider heating load and also solar PV generation is not like our regular load, because for every unit we have 100 amp service, right? Because we can, and then if we go to transformer, actually if you look at over this, your R rate out actually is considered the overall average, the usage will be the peak load profile will be lower than kind of 50 amp, because we consider IV units, they are not watch TV at the same time. They are not use dryer at the same time, so you can discount it. But if you consider the heating, if IV house use air source heat pump, they will heat their house exactly at the same time when the outdoor temperature is low. And then when they are equipped with the solar PV, they will generate solar PV. The peak will occur at the same time because it depends on the sunshine. So for that will be totally change the energy profile of all those buildings. But we don't know how much it changed, whether we need to increase the service level, whether all those transformers not big enough. So for that is one of the reasons for this project. We want to build all those homes. We want to have the solar PV on the top, and then we will see how the real energy profile, a real number is. But that is, and then Dr. Chen's team will analyze all those numbers and find a pattern and build a tool for us and also for the entire industry to kind of simulate, to forecast what energy performance will be if the entire community is go to a net zero ready or net zero standard. Yeah, here is the project milestone is at where we are at. We already passed the milestone 1, and then now we are in the milestone 2 in terms of construction. Here is the real picture of the building, net zero ready building. We will get it probably done in early December, and then we will start to do the energy monitoring and collect performance data for a year, and yeah, hopefully at that time we can have another seminar and then to share our findings. Now I will pass the stage to Dr. Chen to introduce the energy monitoring system.
Sorry, I didn't know I'm supposed to speak up. So I was still in my classroom and I was showing the webinar to my students. I just finished my course. Okay. So hi, I'm Yu Xiang. I'm from the U of A. So I help Haitao on the energy monitoring of this project. We used a system from a Blue Tech, a company in Ontario. So you can see we have something what we call a GEM. Basically, it's collecting all the data from different sensors. We have a sensor we call the CT, current transformer, that measures the current in the electrical box for each outlet. So we monitor how much energy is being consumed by the heat pump, or how much electricity is being generated by the PV systems and all the major appliances. And then we also monitor the flow rates of the hot water and cold water and their temperatures through these thermocouples. And then we also monitor the gas consumption, the natural gas consumption. So we work with the local natural gas provider. They give us a special type of gas meter that can fit the data into our system, right, the GEM. And then the GEM will communicate with another device called the dashboard. The dashboard will transfer the data to a cloud server, and then we can download data from the cloud server for our data analysis. We try to take some photos. Next slide, please. Yeah, we try to take some photos from the buildings, but not all the sensor has been installed yet. So on the left side photo, we see the gas meters. We will wire the gas meter into our jam system. So this is the junction box we have. We're going to run the wire from here to each of these gas meters, and then get the data to our jam, the data logger. And then here shows the jam. We remove the cover. So on the right side, on the right photo, you see I'm not sure you can see my mouse, but anyway, the lower right corner, right, the box here is the jam. So you can see the CT, right, is installed inside the electrical panel, and then the CT runs through this metal cable and connect it into the jam. The same thing is we're going to do the same thing for the gas meters. There will be a wire, a cable that goes from the gas meter to the jam and collect data, right? So that's how much I have from my side. Thank you, Haitao.
Okay, thanks, Dr. Chen. So this is kind of concludes our presentation. I hope the information is helpful to everyone. So thank you to spend time with us, and just probably we have the last 10 minutes also. So if you have any questions, yeah, you can. Now it's time.
Thank you very much, Haitao and Dr. Chen. We do have quite a few questions in the chat. Maybe the best way to go about it is, because I've seen there's some activity from Grant and Karine. If you want to unmute and maybe ask your most pertinent question, and we can try to get everyone to get a question in here before we run out of time at 1 o'clock here.
Sure, thank you. I was just curious in terms of costing for net zero ready for the townhomes. You did some in the stack configuration versus more side by side. Did you find the cost of construction was about the same per unit, or was it cheaper to do them in a stack configuration?
Actually, yeah, because the stack is hard to say. Maybe the stacks are a little bit cheaper, but because the building envelope, we didn't do kind of unit by unit evaluation, because the stack units are on the end, right? So for sure, the building envelope, the cost of building envelope, which higher for the stack unit because they have a long side walls. So right. We just kind of average it out for all the units. And then the mechanical units for the stack units are much cheaper than the hybrid system, right? So if we just add it up, yes, the stack units are about 30% of cheaper than the standard townhome units, and the overall cost is the overall cost increase, not include the land. It will be about 6 to 8% of the total budget.
Right. Okay. And the construction of your townhome units, they were wood framed. I saw that there was no concrete in terms of ICF or pre-stressed concrete.
No.
Okay.
We try to avoid the concrete in the above ground. The structure, for sure, the foundation will be, foundation wall and is concrete, but about the ground, it's wood structure.
And done that way because it's much cheaper or faster to build?
It's kind of much cheaper. And also, I didn't mention here because probably a landmark group has a prefabrication for city here in Edmonton. So all our houses built in Edmonton area actually prefabricated into panels in the plant. So we will ship the panel to the side and then kind of erect the house on site. So all the building components are pre-made are in our factory.
Very interesting. That's great to know. We're looking at townhomes stacked on slab. So very interesting to learn from your experiences there. In terms of sound and fire separation in the stacked, you obviously addressed that based on building code, resilient channel, blown in, cellulose insulation, etc. Okay.
Yeah. For that, I think it is standard. It's kind of standard. Yeah, standard for especially for the stack units. Yeah, there's a lot of fire separation and acoustic performance of the floors. But for that is one of the key.
And I think, sorry, your roofing design as well. I saw you had the panels on one side, so obviously split based on the orientation of the roof design, depending on solar gain for the PV. I'm assuming you did it also the opposite direction based on orientation of your townhomes in the site plan there. So instead of a side to side with center, For that is actually our roof profile is really for a net zero ready homes. Although there's normally there's no solar PV on the rooftop, not required, because we want to get the CHBA label for all those buildings. So although it's not required, but you need to show you have the roof space to accommodate enough solar to offset all the energy consumption. So the roof design is mainly based on the orientation. For all those buildings, we need to design that type of roof. If we have a chance, we can go to our another jobs. And then also is a NZEr ready MURB, the same layout of the units, but the roof design are totally different because of the orientation. So for that is one thing. Yeah, you need when in your design you need to consider. It was interesting. I saw your energy generation for the photovoltaic was about 4 to 5 kilowatt hours. Usually it's 8 to 10 is kind of the target. Was there a reason for that, or just because of the roof space on the MURB with the townhomes?
Because we are actually for this one, it's a net zero ready, right? We want to achieve that goal. The solar PV is we are not to use the solar generation to offset 100% of the energy consumption of the unit. So we just put a small system. So it's enough to cover all the on-site usage, and then for that is mainly for our second goal of the project. We want to quantify what is the interaction between solar generation and the energy consumption of the unit. So for that is why we put it in a small solar PV system. and also save some cost.
Cost, yeah, absolutely. Thank you, Haitao.
Okay, no problem. You're welcome.
Thank you, Grant. I do see another question here from Jesse, also with a bit of a discussion about how do the construction costs and energy costs compare with standard build?
Well, for that, I answer a little bit. The a construction cost is about the incremental cost to achieve a net zero ready for those townhome is about 6 to 8% of the total project budget, the building budget, not include the land. So for that is, and then the operation cost, we did the kind of analysis. Although we reduce the energy consumption, but because we use electricity, it's more expensive to heat the house. So actually the homeowners, they are not save on the operation cost. So mainly, even for stack units, they pay a little bit more. And for the standard townhome unit, they pay a kind of little bit less, but it's you can just calculate the payback for the investment. Yeah.
Sure, Jesse, feel free to unmute if you have a follow-up question there.
Nope, all good. Appreciate the answer, Haitao.
Okay, no problem. Yeah, I just see whether there are any questions in the chat.
I think we've got one more from Tim there at the very end there. As Alberta greens its grids, do we expect electrical generation to catch up to natural gas in terms of efficiency? And what is the import of this technology for existing buildings and deep energy retrofits?
I don't know, because I see a lot of permits from Alberta government to green it is electricity grid, but I don't think it will be in the foreseeable future. It will be as low as the natural gas, because now Alberta has a plan to close all, to shut down all those coal fire plant, but it replaced with the natural gas plant. So if you consider the efficiency of the kind of the grid delivery, so it always will be higher than to use a natural gas on site to heat your house. So unless we like Ontario to go to other source of energy generation, like Ontario has a nuclear, has a big portion of their energy portfolio, or go to a renewable energy like solar PV, like solar PV and wind. I don't see at least in next 10 years, it will be greener than today for sure, but probably it's not as low as what we see in Ontario and BC.
Thank you, Pam. If you have a question, feel free to unmute and join us.
Just can't help it. Just curious, and I've seen a few comments come through in the chat with regards to potential envelope improvements. And I'm wondering if you've looked at for the envelope on a net zero energy ready design, or even net zero energy buildings, and if there's additional opportunities to improve the R value of the walls or any other kind of component of the envelope.
Yeah, for sure, we are consider that, because in this one we use 1 inch of XPS for the building envelope is kind of standard. Actually, it's kind of minimum size. But now we have new project. Probably you know, in Edmonton we have for Blatchford, the city central airport. A landmark will be one of the builders in the second stage, their second stage development, and we are considering to it will be high on the townhome. So we have on the budget side we have more room to play with. So we are considering to have a net zero design, at least a net zero ready design for the homes there. So we will consider all kind of options and the products, right? Yeah, sure.
Great. Well, thank you so much again, Haitao and Dr. Chen. We're running to 1 o'clock here, so we'll be winding up. Just a reminder again, if you do want to catch up with this recording, it's going to be available on the website. So feel free to go check that out. And if you have follow-up questions, you can also reach out to us at SErea. Send a message either to kat@serea.ca or Pam, and we'll get back to you. Thanks again, everyone.
Okay, thank you.
Fantastic.
Bye.